this video, we're going to do a little bit of Calculus 1. We're going to do an optimization problem. We're going to find the numbers whose sum is 20, and the product of the two numbers is a maximum. So we're going to let x equal the first number, and we're going to let 20 minus x be the second number. Okay, so we're going to multiply these two together. So we're going to say that their product, we're going to say that this is p as a function of x equals x times 20 minus x. So p of x is going to equal 20x minus x squared. So in order to find the maximum, we're going to have to take the derivative. So that's going to be p prime of x. So our derivative is going to be 20 minus 2x. Then in order to maximize this, we're going to set this equal to 0. So we're going to say that 0 equals 20 minus 2x. Let's add 2x to both sides. So 2x equals 20, then dividing both sides by 2, we'll see that x equals 10. So if x is 10, that's our first number. And 20 minus x, well, 20 minus 10 will be our second number, and our second number is also 10. Okay, so there's a quick example of an optimization problem. So let's take a look at another optimization problem while we're at it. So this problem is going to be a little bit more difficult, and we might even have to draw a little picture for you here. So here's my stickman coordinate system, and we're going to use the equation y equals negative x plus 4. So we're going to find a point on the line y equals negative x plus 4 and match that versus the origin. So we want to find what point on this line somewhere will give us the minimum distance between the line y equals negative x plus 4 and the origin. So we need to use the distance formula. Well, you may recall that the distance formula said that we're going to take the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, so what are our 2 points? Well, the origin is the point 0, 0, and any given point on the line y equals negative x plus 4 will have the address x and negative x plus 4, because after all, y is what? Negative x plus 4. So we're going to do the distance formula involving these 2 points. So we're going to say that our distance formula as a function of x, because we only have one variable here, is going to equal x minus 0 squared plus negative x plus 4 minus 0 squared, and then we're going to take the square root of that. So let's rewrite that in a little bit more calculus-friendly terms. So this is going to be x squared. So x minus 0 squared is just x squared. Then we're going to have plus the square of negative x plus 4. And then all of this will be raised to the 1/2 power. So let's go ahead and expand the binomial inside here. So we're going to say our distance as a function of x is going to equal x squared plus, well, when we FOIL all this out, we're going to get x squared plus 8x. I'm sorry, that's going to be minus 8x plus 16. And all of this is still to the 1/2 power. So let's combine some like terms here. So we're going to have 2x squared minus 8x plus 16 to the 1/2 power. So that's our distance as a function of x. So let's go ahead and take the derivative here. So d prime of x then is going to equal 1/2 times 2x squared minus 8x plus 16 to the negative 1/2 times the derivative of the inside, which is going to be 4x minus 8. So now let's clean that up a little bit. So if we multiply 1/2 times 4x minus 8, we're going to get 2x minus 4. And then this square root is going to go to the bottom, because it's to the negative 1/2 power. And we're going to set that equal to 0. So in order for this to be 0, that means the top has to be 0. So that means that 2x minus 4 has to equal 0. So that means that 2x has to equal 4, therefore x has to equal 2. So the x value of the point we're talking about is 2. So now let's put that back into our original equation, which says that y equals negative x, which is 2, plus 4, so that's going to equal 2. So the x value of our point is 2, and the y value of our point is 2. So the point that we're looking for is 2, comma 2. So there's yet another optimization problem in Calculus 1. Thank you for watching.